Hello and welcome. Welcome back to making a across the road Frogger-like arcade game. Yesterday we managed to use a tile map to draw a grid of tiles. Today we'll be looking at drawing a player to the screen and adding player movement. Let's get right into it. So here we are in Godot, and let's get right started. To draw the player on the screen, all we need to do is to draw this image here onto the game area. I'll see if okay, so if I put it there, then it is hidden behind the tile map. So I guess that tells us that the order of these things here in the scene view matters. All right, so let's see. On the right here, we have something called a transform. The fact that it is under node 2D here means that everything that derives or has the ancestor of a node 2D has this property. And the transform is basically a graphics term for position, or like how it is drawn. So if we set this to 0, 0, let's see where our guy goes. Okay, so turns out this is the 0, 0. The 0th position of our game. I'll quickly maybe move the tile map there as well. So 0 and 0. And let's see what we get. Okay. So okay, I guess it doesn't really matter where we put the player to begin with. Yeah, we can keep it there for now. I also want to go to here and click on centered. And this makes it so that it is the origin, or like the point from which all the calculations are started, is the top left, like this part here. So now this should align with this tile, or like the corners here of the player and the tile should align. I can also see if I hover, or can I see? Okay, so I can, this is the width, and this is the height. So if the width is 88, and the, oh my god, I need to get a calculator for this. 1 second. So I'm trying to understand what should the position be if I want the player to appear in the middle of the square. So if my square is 128 pixels wide, then the center of it, it'll be 64. So if I add, let's say add 64 to the position, then now it is, now the origin, the top right, is in the middle of the square. Now if I subtract half of the width, so that's 88 divided by 2, that's 44. If I do, okay, and a quick tip here, you can do operations here, so you can do 64 minus 44, and yeah, perfect. And that should be, it should be centered now, horizontally. And for the height, again, so we can do 64. And now 107, let's round up to 108 divided by 2 equals 54, so minus 54. Okay, so that looks centered enough for me. We can save. And yeah, let's go. Okay, so I guess technically this means that goal 1 has been achieved. We are drawing the player on the screen. That's correct. But it's not very impressive. So let's go and add movement as well. And to do that, we need to add our first script. We'll pick the cat node and right-click and go to attach script. This will give us this window. gives us some basic options about scripts. And I'm going to go here and tick on for the built-in script, and I'll give it a name as well. The difference here is that with a built-in script, it doesn't actually generate a file. It is just tied to this node, which means that you cannot use the script in any other object, and you cannot edit it in an external code editor. But I think that's fine, and I prefer this because, at least for small projects, it means less files, so there's less clutter. So I'll go and create. And now we get the default properties, or like the default functions in a script. So let's go through this line by line. This says extends sprite2d. Sprite2d is like a class if you know programming. If you don't, then it just consider it like a bunch of properties, options, and functionality that is grouped together. And it's possible to have a chain of these ancestors and parents, where each one will inherit all the functionality and properties of the ones that come before it. So if I press Control and click on Sprite2D, I will be taken to the documentation. And here you can see that the class is Sprite2D. This inherits from node, which inherits from canvas item, which inherits from node, which inherits from object. So all of these have their own properties and methods, and everything that inherits from those, no matter how deep down it gets, they have access to these. So it's a good way of sharing functionality across different things. Here we have two functions. They are called, we can think of them as callback functions if you know about programming. If you don't, then that's fine. We'll just need to know that when these functions are called or when they are executed. So ready, as it says here, when this enters the scene tree, this function will be called, and process will be called every frame. So this is like the game loop. Every time the game is drawn to the screen, this function is called. And to call a function, to execute a function, just means that it will run all the code that is within that function. So basically everything that I type here will be run. So if I do print I, print means print to the console. There is this console here. If I go to output, then like there's a bunch of messages. And now if I would run the game, I will see hi being printed here as well, 60 times per second, because that is how often process will be called. So drawing 60 times every second. Let's try that. I will quickly go to game. And now we can use this hi. It just keeps on going. It's being called and again, then again, and again. I will quit the game. And yeah, so that's the quick demonstration. So what we will need to do is we need to check if at any time the player is pressing a certain key. And when they are, then we need to move our character accordingly. So let's set that up. For that, we can use an if statement. This just means that whenever what follows evaluates to true or is true at that point of the program's lifecycle, the following code will run. So we can do if input dot is action just pressed, let's say, and we'll do UI right, then colon. Now we are in the if statement. So now we can do things, or rather, this code will be executed when the player presses the button that corresponds to UI right, which is the right arrow in our case at the moment by default. And I'll just log right. So now if I run the game and I will press right a few times, then we can see that this is logged to the console. So that's great. Before we do anything else, I'll just duplicate this 3 times so that we have one branch for UI right, one for UI left, UI up, and actually I don't need down because I don't think you can move down. So I'll skip down for now. Now this is yelling at me because it's like it says, it expects there to be something after the it block. It cannot just be empty. So I'll just write pass for now, which just means that it just means do nothing, and I'll save. Perfect. There we go. So now what can we do? So let's say that, so we have a grid of squares. We know that the square is, oh hello, my cat just jumped on the table. I'm your cat. We know that the square has a width of 128. So up here I'm going to define a constant, which is a variable. So this just means that instead of writing 128, I can write this variable in its place. And I'm going to call it tile width, and I'm going to set it to 128. And const means that this is not expected to change during the life cycle of the program. This will always be the same. It will be a constant. So here we can now go to the right branch and say global position dot x, so the horizontal axis, equals global position dot x, so the same that we have now, plus tile width, and save. So this global position property is available on either Sprite2D or something that comes before it. You don't really have to know exactly where it comes from, but you know that it exists. And this is referring to the global position of the cat, because this script is attached to cat. And the reason why it is global position rather than some other position is that there are 2 different coordinates. There's a local position, which means that if cat has a child scene, like let me show you, if I would place another cat under this cat, then this cat would get its global position from this the parent cat, and this position will be relative to the parent cat. So if this is 0, 0, then, and also the offset is offset, then it's on top of the cat. Its position is 0, 0. The parent's position is 20 and 10. So this is relative to the cat. Since we want to move our cat relative to the world, we have to use global position. Now, if I go and play and I press right, cat should jump right by 128 pixels. Let's try. Okay, and it works. So that's great. Now I can just do the same for UI left. I'll just go to X, let's go to here, and it's going to be minus tile width instead, because we need to go to the left. And for up, it's going to be almost the same, but we're going to do Y, because we need to move along the Y axis. And we need to do minus, even though we're going up. Usually in computer graphics, as also in Godot, the origin, the starting point, is in the top left corner, and positive numbers go down and negative numbers go up. So something like 50, if you have a 100 by 100 wide square, then 50, 50, or rather x 50, 50 would be the center. So to go up, we need to subtract the tile width. And I guess now it's no longer width. We can just call it tile size. Again, a quick tip for Godot. If you are using, I think, Godot 4 at least, you can do Control D, and this will select all of the occurrences of whatever you have highlighted, and you can change them at the same time. So very useful. Okay, now I will run the game again, and I should be able to move left, right, up. Right works, left works, and up works as well. Perfect. I think we can call it here. Otherwise, this will become very, very long. I did want to handle obstacles here in this video as well, but I will keep that for another time. So thank you very much. See you soon.